Good morning, everyone. My name is José Cipra. I'm going to present my master thesis. And this time, my presentation is titled Optimizing Fire Severity Mapping in Mediterranean Ecosystems, a comparative analysis of hyperspectral and multispectral vegetation indices. A little bit of context, we know that wildfires in recent decades have been weighed and damaged a lot of landscapes, and is needed to assess this with the fire severity, like using methods like remote sensing for assessing this type of indicators. And also to use these images to get some vegetation indices that can highlight the characteristic of these burn landscapes. And I like this image because it's kind of confused. At first glance, I thought that was kind of a volcano, but in the quote of this image was mentioned, it's like a volcano, but it's a burnt forest. So the objective of this research was to evaluate the performance of the vegetation indices derived from multispectral and hyperspectral data to estimate the fire severity across Sierra de la Culebra wildfire. The method used for this was to evaluate this area, only Sierra de la Culebra, because there's another area next to it, and it was located in Zamora, Castilla y León, and the fair date was between 15th and 19th, 2022, and the affected area was around 28,000 hectares. The sampling method was random stratified, and the plots were of 30 by 30 meters square, a total of 70 plots. And the ecosystems evaluated were coniferous forests, broadleaf forests, and shrublands. As you can see in the map, we have the three ecosystems there, and also the plots in the yellow dots. How can we assess the fire severity? Well, we have an index that is called Composite Burn Index, or CBI. And we split it in three types, like it's vegetation CBI, soil CBI, and site CBI. The thresholds to measure which is the higher, the highest or the more level of damage, and the lowest one is the ones who are there is 1.25. Below that threshold, we have a low severity. Between this and 2.25, moderate, and above it, the high severity. As I mentioned in the objective, we use two types of data, hyperspectral and multispectral data. For the hyperspectral, we got the information from the Prisma agency, the Italian one, and from Sentinel, the multispectral. And there are some characteristics that I showed here to see some particularities that we have in this type of data, like the wavelengths and the spatial resolution and the number of bands applied for this study. Also, it's important to mention that we use a bunch of formulas to calculate the vegetation indices, like the classical broad bands indices and the narrow bands. But if you see in this chart, you can notice that we use some of the classical formulas to calculate, to compute the hyperspectral vegetation indices. That's why, because we try to use the most of the knowledge and the information that we have to have the better prediction of the fire severity. The univariate linear regression model between the CBI and the vegetation index was used. We got the different correlations to know what is the best vegetation indices for each of these classifications. And after that, we use the mapping to extrapolate this information. Some of the results are shown here. And you can see in the left part, we got a bunch of vegetation indices and different values that some of them got the highest correlations and some of them lowest. And the same happened with the multispectral data in the right side, but because we don't have many bands, so we didn't have many data to plot. Here we have some of the results that we got. This is for the hyperspectral images. And we can see that the vegetation CVI with shrublands and broadleaf was the ones who got the highest correlationships, and we use this for the next step. And here we have the multispectral, and we can see more or less the same trend as we present in the previous one. After plotting the vegetation indices in the maps and extrapolating the whole area, we got the proportion of the low, the moderate, and the high severity in Sierra de la Culebra area. And we can see some differences comparing, for example, the third and the fourth, because the third is related to hyperspectral soil and the fourth about the multispectral soil. We can see that the moderate level is different, or the high level is a little bit less than that was produced in the hyperspectral. So we can see some differences in this type of results. As a conclusion or the takeaways messages, we can say that the hyperspectral indices provide superior estimates for the fire severity in Sierra de la Culebra, where the CVI at the vegetation level got the stronger correlationships. And also the broadleaf forest with the shrublands had the best correlation with the CVI, where the cellulose absorption index and the normalized vegetation red edge index were the ones who got the best correlation in this study. And you can have here the paper published recently of part that was about this study. And thank you so much for your attention.